Hi, everybody. Oh, that was pitiful. Just terrible. Try again. Hi. Hi. Yes, this is good stuff. I was questioning up until about 5 minutes ago why, oh why, I got on a plane, a flying sardine can full of COVID patients, and came here. And now I know why. I am so happy to see you all. It is so good to see you all. It has been a long time. This is my first trip abroad since the pandemic, which is, oh yeah, all right, good stuff. Good stuff. Oh yeah, good stuff. No, I appreciate it. I'm so happy to be here before you all today. It has been way too long, entirely too long. My name is Josh Long. I work on the Spring team. I'm a Spring developer advocate, and I am just happy to be here with you all today. And most importantly, I'm at your service. So should you have questions, comments, feedback, whatever, don't hesitate to find me on the internet. Anybody on the internet? Anybody? It's like Hotel California. You can check in, but once, you can never leave. The internet is permanent, man. It's like a tattoo. Anyway, I'm there, and I have stuff that I do. Goodness, I have a podcast. I have a YouTube series called Spring Tips. I have a recent book I wrote called Reactive Spring, the 1.1 edition of which I am working on right now. I have Twitter, LinkedIn. My goodness, I'm just out there. I'm out there, right? Like the virus. I'm just everywhere, So yeah, find me. Some things shouldn't be open source. Virus is one of them, but my stuff is, mostly open source. So go find all that stuff. Oh my goodness, I can't believe we're all here. Can I get a photo? Are you all okay with that? Do I have to worry about Yeah, do I have to worry about that? Do you accept my GDPR cookies? Everybody accepts the GDPR cookies? Okay, if you don't want it, you can just cover your face or something. I don't know how that works. Okay, pretend like you're happy, okay? I'm just so excited to see you all. I think the best way to do it is to get a big photo from over here, and then we'll just, oh yeah. Okay, pretend 1, 2, 3, say open source. Wait, let me get the macro view. My fat face is in the middle. Open source. Oh yeah, thank you. Good stuff. Okay, so welcome everybody. So today we're going to talk about a lot of the new stuff, The trouble is, it's not yet fully baked. It's new. That's the whole point. So we're going to look at a lot of stuff in terms of the latest and greatest from today and foreshadowing the latest and greatest to come. And along the way, I hope we learned something. I certainly learned a lot just pulling it all together. The Spring team goes faster than I do, right? Which is a lot, because you should see the amount of coffee I drink. So I'm always surprised by all the new stuff that's happening in the ecosystem. And hopefully you'll find some interesting bits as well. My friends, we're here to talk about the latest and greatest in Spring. So obviously, what I want to show you, but which I can't really show you just yet, is Spring Framework 6 and Spring Boot 3. But you can try it out. You can try some of the early bits out. But there's not really much to show in terms of code, in terms of API changes here, so I won't be doing that. But we should talk about it, because we're working towards a new generation of Spring Framework. Spring Framework 6 and Spring Boot 3, both of which are due later this year, at the end of the year, 2022, for those of you not keeping track. Spring Framework 6 is a generational change. It's a new baseline. It's a new revision, a new base revision of Spring Framework. The last major revision we released was Spring Framework 5 in 2017 in September. That release will have been 5+ years old by the time we get to Spring Framework 6, right? And so with Spring Framework 6, we have an opportunity to do some major sort of baseline updates. So the first and most jarring of which will be that Spring Framework 6 requires the new Jakarta EE APIs, right? So if you're using Jakarta EE and what used to be called Java EE and what used to be called J2E, that stuff is now a little different than you once knew it. Not for any technical reasons, but because of stuff that we couldn't really change or modify, right? The most jarring change you'll see is that the packages have changed, right? These are for non-technical reasons, and this is not something we could do there's nothing we could really do to change this. It's fine. It's not a big deal. It's going to be the easiest find and replace you've ever seen, right? Ever. So basically, all the javax.asterisk namespaces are now Jakarta.asterisk. So if you're using very well-known, very well-used, very entrenched technologies like JPA, bean validation, all very good stuff, right? Then that stuff's going to be a little bit different. You're going to have to do a little quick and find and replace. I would be very surprised if your IDE doesn't have like a that was easy button, where it just clicks and you just update your code automatically, right? That's the new thing. So because of the way we're doing this, we're integrating the latest and greatest in Jakarta EE. That now, we have to use the Jakarta namespace, so all the code has been updated to reflect that. Again, not a big deal. Everything is basically the same. The Jakarta EE folks have done a great job of slowly tapering off of the old namespace. So they did one version where it was, the same as before, but under the Eclipse Foundation, and then they did another version with the new packages, right? So you have actually two different versions where not much has changed. Basically, it's backwards compatible. And so you can easily take that code and just move it over, and the only thing you can expect as a surprise is the packaging. With that in mind, should be pretty easy, but I just want you to know about that. That's the first big change. The next big change, the one I'm most looking forward to, is Java 17 as the baseline. So, quick question. How many of you are using Java 17? The rest of you, what's wrong with you? Get on this. This is awesome. I love Java 17. The new baseline will be Java 17, but again, consider the context in which we do this, right? We're going to release this new major revision at the end of this year, end of 2022. The last time we will have done that will have been in September of 2017, so 5+ odd years. Did my screen go off? Whatever. It'll be September of 2017, so it'll be 5+ odd years. When we did that, the baseline version was Java 8. Java 8 is long since deprecated, right? No longer a viable choice for anything except for laughs, right? It is completely inadequate in every context. So Java 17 is the new baseline. And consider that now we have a release cycle where every 6 months we see a new version of Java come out, right? So every 6 months you get a new supported version. What it used to be 3 years, now it's 2 years. So every 2 years you get an LTE release of Java. What that means is that if we release in end of this year, we're already at Java 18. There's no reason to expect we won't have a Java 19 before Spring Framework 6 drops. That means that, what is that, 5 years, 2 releases a year, that's 10 revisions. We could be at Java 29 or Java 30 or something like that by the time Spring Framework 7 comes around. So it seems a little aggressive to pin Spring Framework 6 to Java 17 today, maybe, not really, given that it's already a version behind, but it'll certainly seem like a very conservative baseline in 5 years' time, assuming that we extrapolate forward. Now, of course, I don't know when we're going to release Spring Framework 7. It might just be that we release Spring Framework 7, January of 2023. Probably not, but I don't know. I have no idea. No ideas on the timelines. But I'm just saying, given 5 years, a lot can change. So Spring Framework being based on Java 17 is a good thing, TM. Okay, so that's going to be, and that's really nice because that means that we can write Java 17 isms in the Spring Framework itself. Okay, so these things you can already try out. This is the stuff you can already try out in your code right now. You can go online, go to start.spring.io, download the early milestones and releases of Spring Boot 3, which is built on Spring Framework 7, and you'll be able to try out Spring Framework 6, and you'll be able to try all this out. Okay, good. So now that we kind of got that housekeeping out of the way, let's kind of look at some of these features here. Good stuff. Good stuff. Okay, so in order to kind of appreciate everything, I'm going to look at the latest and greatest in the current generation, and then we'll look at Spring Boot 2.7 as well. Obviously, when I'm going to do this by going to my second favorite place on the internet. Who knows my second favorite place on the internet? Thank you. Spring.start.io. Yeah, exactly. Start.spring.io. My first favorite place on the internet. Anybody know? Production. Yes, exactly. I love production. You too should love production. Just go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It's better than Disneyland and a far sight better than Euro Disney. Way better. Way better. Anyway, I love production. You should love production, right? So we're gonna, if we haven't already gotten to production, you can begin your journey here at start.spring.io. We're gonna build a new service. As always, I'm gonna call this customers because I can. And we have before us some choices. The first of which is the choice of the version of Java that you want to use. Obviously, I'm going to use Java 17. Like I said, Java 17 is faster, more secure, more performant, more robust, more capable, more secure, more operations friendly, and technically superior in every way to Java 8. In every way. It's also morally superior to Java 8 in every way. You won't like the look of shame and disgust in your children's eyes when they find out that you're using Java 8 in production. Don't do it. Do the right thing. Be the change you want to see in the world. Use Java 17. Java 17 is the right thing to do in 2022. Now, just judging purely by the number of the version, Java 17 is more than twice as good. as Java 8. I mean, I think I've made my case. I don't need to elaborate. Anyway, we're going to use Java 17. It's good stuff. We're going to bring in the reactive web support. We're going to bring in H2. We're going to bring in R2DBC. I suppose maybe we can bring in the actuator. Let's just see how much time we have. I don't know. So I'm going to bring in all these bits. The benefit here is I'm using reactive APIs. I like reactive APIs because they give me several big benefits. I still talk about reactive APIs because I think it's just become table stakes to build applications responsibly at scale, right? If you're building software today and you want 3 big benefits, I don't see an easier way to get them than to use reactive programming. Now, reactive programming solves 3 big problems. One is giving me a programming model so that I can make better use of my threads, okay? That's one big benefit. Now, of course, obviously, that benefit is because right now, at the moment, as we're talking in middle of early 2022, basically, at the moment, threads are very expensive. It's not cheap to create a new thread on the JVM right now, right? And so as a result, you want to be as precious with these threads as you can. You want to make sure you don't waste them and create them wantonly. You're not going to be able to create hundreds of thousands of threads right now. And if you want to solve the C10K problem, right, which is a question of how many concurrent socket acceptances could you do right now, that wouldn't be great if you did a socket per request model, right? Now, it is possible to create, 10,000 concurrent file descriptors. You can create 10,000 concurrent sockets on your operating system. You just can't create 10,000 threads. So what reactive programming does is it gives us a way to break apart that request per thread model. And that allows us to unlock these performance benefits that you get. So the way this works is you take advantage of asynchronous programming while you're waiting, while your runtime is waiting for something asynchronously. It is free. The thread is free. Something else in the system can use it. That's why I like reactive programming. That's one benefit. Now, obviously, Project Loom looms. Right? Project Loom is awesome. I cannot wait for Project Loom. Project Loom gives us green threads or fibers or whatever you want to think about it, right? And this will make the cost of creating threads much smaller, right? But it's still threads, right? Threads are not, remember, only one person really knows how to write multi-threaded Java code. And it's not me, right? It's not you either. I don't know who it is. But the point is there's only one person out there who does. And since it's not us, let's not do them, let's not use them if we can avoid it, right? Remember, Tony Hoare and all these amazing people created like actors and all this stuff in the 70s, right? There have been better models for building systems at scale, for doing concurrency at scale for 50 odd plus years. If you had told somebody in the 70s that we'd still be based on threads and locks, it would have been laughable, right? Seems even more laughable now in the world of multi-scale and scale out and all that. So reactive programming unlocks that potential for us. It gives us 2 other big benefits, which is it gives us because it's all one abstraction, everything becomes one type of thing. You get data from Kafka, you get data from RabbitMQ, from a web endpoint, from WebSockets, from RSocket, from all these different sources, and it's all one kind of stuff. It's a reactive stream. And these things compose well together, right? So it becomes much simpler. So much of the tedium, so much of the difficulty in writing distributed systems and building services these days, even if you just have a handful of them, is that they speak different protocols, right? This is a problem because I don't want to write that glue code. Let's say I want to take the data from Kafka and I want to send it out to a WebSocket endpoint. I want that data to go down. These have different life cycles. They have different APIs. They don't speak to each other the natural way. So you have to write this glue code to arrange it so that data from the, maybe you get a blocking queue or something like that, so you can take the data from Kafka and then put it in a place where the WebSocket can consume it and whatever. All that goes away when it's all just reactive streams. Life becomes much easier. So I like having one kind of stuff. It also lets you it makes it much easier to think about the big picture of what you're trying to do, how the data moves through the system. And the reason it does that is because you have a single abstraction that allows you to think in terms of functional programming, right? Reactive programming implicitly is also functional programming. That functional programming makes it very easy to compose different pipelines, to take different operators and reuse them in different places, rather than having these stateful sort of sequential state mutation trees. That's one benefit. That's the second big benefit of reactive programming. The third is that because we have the single abstraction, the single core abstraction, we have a nice place in which to interpose things like robustness operators, reliability, retries, timeouts, back pressure, all that kind of stuff. So I just want to state in 2022 that I take for granted reactive programming, but if you don't, now hopefully you understand why I do. Okay, so we're going to use Java 17. We got the Spring Boot actuator, we got the reactive data access layer, we got H2, good stuff. Let's hit generate. And all I'm going to do here is I'm going to build a simple application that talks to my little database. We're not going to waste too much time here. I just want to get this up and running very quickly. I might need to change the font, my friends. Yeah, I certainly do. Let me see here. Font, custom font. No, wait, I wonder if I can I think I actually fixed this. You know, it's been so long. I've been writing code on a monitor. It feels very weird to use this IDE on a laptop like this. Actually, one of the other things I couldn't do on all those Zoom calls that I've missed so very, very much, check this out. Start.spring.io. Oh, it's so satisfying. I would do this. Whenever I did a presentation on Zoom, I would do this part, right? I care about this part. But that Zoom effect doesn't work. It doesn't translate over Zoom. For some reason, it doesn't. It's so tedious. Like, anyway, thank you, Zoom, for getting me through the pandemic. But please fix that. Anyway, so we have a brand new application. It's just an application that's going to talk to a database. I'm going to have an entity here of type customer. It's going to have an ID. It's going to have a field called name. And the ID, the field here is ID. There you go. Now this is a record. This is something that has getters, but it doesn't have mutators, right? It takes its arguments through constructors. This makes life a lot simpler. Notice that I didn't have to bring in Lombok. Lombok's awesome. I love Lombok. But for this kind of stuff, I don't need it anymore, right? There's probably a lot of other use cases. I'm sure there are other use cases that are well served by Lombok. But for creating an entity where you have getters and setters, no more, right? So now, that's a Java 15ism, whatever, but it's now GA, it's in Java itself. I'm going to create a repository, a reactive repository to work with that data, okay? Integer, there, voila, okay. There's my repository. And now I want to create a thing that writes the data to the database. So I'll create a customer runner. It's going to implement application runner. And in this runner, I'm just going to write some data to the database by using the customer repository that we've just defined, yeah? I'll inject this into the constructor. And here, really, I could have just made this a record, couldn't I? I could actually make this a record and define this, but this is kind of gross, but I don't really care. Because what it's going to do is it's going to create a getter for that repository. But, I don't know. I won't tell if you won't, it's fine. Okay, so anyway, I'm gonna write some names to the database here. We're gonna create a names, these are reactive, these are people on the Spring team, so we'll create some names. The good Dr. Sire, I'm Josh, obviously, and this is in no particular order, I'm just thinking aloud here. Jürgen, of course, the one, the only, the man, the myth, the legend, Jürgen Holler. We've got Olga, we've got Yushin, we've got Violetta, we've got Madura, we've got Stefan, right? Is that 8 yet? Did I do 8? Let's see. Oh, yeah, that's 4 and 4. Yeah, so there's 8 names. And what I'm going to do is I'm going to take each name and turn it into a new customer, customer. Okay, like that. And then I'm going to take each one of those, I'm going to write it to the database thusly, right? So this repository.save. Yeah. So all I'm doing is I'm writing that to the database, and then I just want to, as they're written, I want to just consume them thusly. Okay. So system.out println. Okay. And finally, I want to build a simple HTTP endpoint. Okay. A little REST-y style endpoint, not an actual proper REST endpoint, but an HTTP endpoint that I'll, for simplicity, call a REST endpoint. Okay. So customer REST controller, and again, records, so cute. So good. Okay, so here's my customer repository. And again, don't tell anybody this. And I'm just going to return all the data, yeah? So publisher, customer, get, return this dot find all. Voila. Okay, let's go ahead and restart this. Let's see what that gets us. If everything goes to plan, then we should have 8 names in the database. Okay, oops, I did something wrong. Table customer not found. Fair point. Okay, so resources. Okay, file customers. Schema.sql. I'll say create table customer ID serial primary key name varchar 255 not null. By the way, I saw a thing on the internet, not to do with this. I saw a thing on the internet. And I can't really unsee it. I have a question. If you had the letters in this order, C, and then L, and then I, how would you spell that? How would you say that to another human being with spoken language? You wouldn't say Klee, right? You wouldn't, right? Am I wrong? Have I been doing it wrong all these years? I didn't know you could say it that way, and it's... I just, and apparently it's a thing. Apparently it's not, it's just, I mean, obviously, phonetics being what they are in different languages, each, it's not wrong. I just didn't know. I didn't know that was a thing. So all this time I've been talking about CLIs. There's a sizable population that has no idea about what I'm speaking. They're expecting me to say CLI, which just sounds, to me at least, it strikes me as a little different. Okay. All right, good stuff. There we are. There's our names. There's our 8 records. It's worked. Of course it worked. It was a demo. It was a demo. Now, obviously, at this point, I normally talk to people about the ASCII artwork. That's another big change. So you know that they have this, they've done a better job. The folks over at JetBrains have done a great job here. They've hidden the most insulting of features deep down in the menu here. So you have to choose this to hide the banner, right? Which is a terrible option. Right? There's a Spring Boot ASCII art banner. It's now hidden. And in that vein, I wanted to talk to you about a thing that's happening because we're going to be supporting Spring Native. Or we're going to be supporting GraalVM, right? And because that feature, we've got a feature which allows you to do text banners, and you can just put a file called banner.txt under source main resources. That'll show up in the console. One of the other features that we added a few years ago, and this is again one of those backwards incompatible changes about which we're very sorry. One of the big things that we added a few years ago that we're now taking away is that you can put banner.jpg or banner.gif. I'm not going to pronounce GIF because there's no right way to say it. You could put that file under source main resources, and it would turn it into text for you right now. Did you know that in Spring Boot currently? So you could do an animated GIF, right? You could put that and it'll turn it into animated text, a curses-based, readline-based thing in the current versions of Spring Boot. But we're taking that away. That animated thing, the turning images into text is going away. So you'd have to just go to a website and take the image and upload it and turn it into text there and then copy and paste it into banner.txt and it'll continue to work. I know. The room just went dead in despair. Okay, so we've got our records. We've got our eight records in the database. It's working fine. Now, obviously, I want to take this to production, right? I've got an application, and I just mentioned GraalVM. A big feature in Spring Framework 6 and in Spring Boot 3 is GraalVM-native image support. Now, how many of you know GraalVM? GraalVM was originally conceived as an OpenJDK replacement. It is a hotspot replacement, right? You drop it in, and it replaces the default out-of-the-box just-in-time compiler. Hotspot has served us well, but for a long time, it's been there for a long time, and it's kind of grown into this morass of spaghetti C++ code. So to make that easier, they developed a just-in-time replacement built on Java. That's the original use case for GraalVM. However, think about what the just-in-time compiler does. It takes your code and adaptively turns it into native code. It's such a common dynamic that, in fact, people have gotten to the point where large organizations, they just pre-deploy and they exercise their code before they turn it in, before they let it loose in the general public. So they exercise it in production to warm it up so as to trigger the just-in-time compilation. This is great because it means that a mediocre Java application can actually, in some cases, be faster than a well-written C or C++ application for lots of different reasons. But not least of all is that we can see in a single place all the memory, right? Java can see the whole world picture of the memory data flow, and it can optimize for that. Whereas with C, you've got resource acquisition is initialization, where you have to constantly allocate and free memory, and you get these little hiccups of memory, right, in those kinds of programs. So Java is amazing. That just-in-time compiler is amazing. So the obvious question then is, why don't we just proactively turn everything into native code if we can do that, right? Why not? And we can now. That's what the GraalVM native image compiler does for you. The problem is GraalVM hates your code with a passion, with a deep, fiery passion unrivaled by anything else except for perhaps my disdain for PHP code, okay? It's like Java. If you can write Java, why wouldn't you just write Java? It's actually more verbose to write PHP. Never mind. It's not here and there. Anyway, it hates your code. It hates all the things you can do in Java. Java, for all its stodginess and warts, is actually a very dynamic language, right? It has a lot more in common with the likes of Lisp and Lua and Perl and Ruby and Python and JavaScript and whatever than it does systems programming languages of yore like C and C++. That's because it's got a runtime. So you can, at runtime, long after the application has been compiled and started and run, you can, at runtime, take a Java-lang string full of the content of a class file, like class, dog, curly bracket, turn that string into a Java class, write it to the file system, load that class into the class loader, reflectively create an instance of that class, call methods on that instance, serialize that instance if your class implements serializable, and create Java proxies, JDK invocation handler, powered proxies out of that type, all after the application is started. In effect, you have eval in Java, right? And this happens all the time. Remember, Java's been around for what, 20, almost 28 odd years now? It has some amazing capabilities. It's like Lisp. You can change the runtime with the runtime, right? And so because of this dynamic behavior, GraalVM sometimes gets you into some trouble because GraalVM wants to throw away all the stuff that it cannot see at compile time. It can't deterministically see that you're going to use at runtime. It throws it all away. That's its default instinct. So every time you start up, every time you compile an application, it throws away all the stuff it perceives you aren't going to use or that you're not reaching directly. So when we talk about reachability in GraalVM, reachability is the idea that you have code that you're using and it's calling some other code and it's calling some other code. As long as it can see that connection, it'll retain those types for you. But it's going to throw everything away, which is a bit like throwing the baby out with the bathwater, isn't it? Right? So you need to give it some information about what you plan to do. And if you do that, it'll retain those types. It'll make it work. It'll allow you to call reflection methods and do serialization and load resources from jars, even though there's no concept of a jar in GraalVM, right? So you can have like a banner.txt in your jar, and it'll still work if you load it in the GraalVM world. But you have to provide that configuration. And there's a lot of places where this kind of stuff gets done, especially in frameworks like Spring and all the stuff that Spring integrates with. So we created a project called Spring.next. Spring.next is a research bed that we've had for, I don't know, what years now? 2022, so 2019, 3 years, where we've been sort of developing all the things that we need to make it easy to turn applications into native applications. It's a compiler. It's a compile time mechanism that looks at your code and understands all the common patterns for Spring-based code and generates that configuration to feed into the native image compiler. That mechanism is a separate project that you can use today with Spring Framework 5 and Spring Boot 2.x, okay? But a lot of that will be folded into Spring Framework 6 by default, and the compiler plugin machinery will be in Spring Boot 3, okay? So we can look at some of that right now. So let's change our application by going here, and I'm going to add Spring Native. You can see in big bold letters, experimental, right? We don't want this to be your final destination. Spring Framework 6 is where you should go. So I'm going to copy and paste all that. If the button loads, copy. All right, good stuff. Paste, okay. And so what that's done is added the GraalVM native image compiler. It's added the test support, so you can run your tests in a native image if you want. It's added the milestone repositories for your code. It's added the Spring AOT Maven plugin. I expect that a lot of this stuff will just be folded into the Spring Boot plugin in the future. Right now, Spring Native is a separate project. We haven't changed Spring Boot 2 or Spring Framework 5 to make it work, really. We don't need to because it's easy enough to do from outside. But to make it even more streamlined and to reduce on some of this verbosity, Spring Framework 6 and Spring Boot 3 will just have it all in one piece, right? So that AOT plugin is there for now. It's a central piece of the Spring Native story, but it's not, I don't think, a fixture of your code for long. We don't need this dependency. We're not using it. And then we got Spring Native itself, the dependency here, okay? So Spring Native has a very small runtime footprint, and most of this is used at compile time, okay? This is all compile time stuff. This is a component model that exists entirely at compile time. And what happens is we have an SPI that you can use, kind of like Spring Boot auto configuration, where Spring Boot auto configuration happens at startup time, the Spring Native stuff happens at compile time. And we actually create a sort of a husk of your object graph. We create an application context at compile time, but we don't start anything. So we create the beans, we know about how the beans relate to each other, we know what shape they're going to take, and we use that, we give your component model, we give the Spring Native component model a callback, and any particular configuration can contribute hints. These are called hints that feed into the GraalVM native image compiler to tell the GraalVM native image compiler about things like reflection, about proxies, about resource loading, about JNI, about all the stuff that GraalVM so very, very hates, okay? Now, this is here on the class path. I don't need to do anything else. I'm going to go to my application here, and we're going to compile it. Now, I'm going to skip tests because this is the effect of having tests is that it'll compile the tests as a native application, run them, and then compile the regular code, the production code, and then run them, which means that the compilation takes a little while. And as you'll see, I don't want to wait twice as long. So I'm going to skip tests because ain't nobody got time for that. We're just going to build them and go. Now again, this is going to analyze all of your code. So this is why GraalVM takes a little longer than your regular Java application. It's actually analyzing not just your Java code, It's not. It's actually analyzing your .class files, but it's not going to analyze just your your code. It's going to analyze everything that it touches, everything on the class path each time. So my hope is that one day there'll be some sort of index mechanism where we can pre-compute, some of these hashes, some of these indexes that have to be built each time. We can pre-compute them and store them in some sort of Maven central kind of thing. If only we had that, and maybe that would short-circuit some of this compilation, this work that has to be done on every single compilation. In the meantime, it takes like a minute or maybe a minute and a half. I don't know. If you're running Slack, it's considerably longer, right? Slack's fine. It got me through the pandemic. What do I care? It's fine. Anyway, we do the configuration to tell GraalVM about all the different places where frameworks do these dynamic things. Okay. We also use Spring Native to, wherever possible, avoid doing some of these dynamic things. So the Spring AOT Maven plugin is a clearinghouse for transformations that run against your source code. Transformations that hopefully a minute. There you go, a minute and 8 seconds. Hopefully sidestep some of these dynamic behaviors. Okay, so if you look here in the target directory, you can see that we've got our classes, org, meta-inf, native image. So first of all, here's the configuration files. These are all the different config files that GraalVM itself expects, the reflect config, the proxy config, resource config, all that stuff. Here's the, this is all fed into GraalVM. This is all generated at compile time by the Spring AOT plugin. But we also generate, let me see here, is it here? Yeah. We also take the Spring.factories mechanism. So Spring.factories is a service loader mechanism. It was built in Spring Framework since Java 6. It sits on top of the Java 6 service loader mechanism. And basically, it's how we do auto configuration. When you add a jar to the class path, that code gets run. If you ever wondered how, it's because of this Spring.factories text file that lives in source main resources, meta-inf, in any jar, your jar, our jar, any jars on the class path. And those all get read at startup time, and their different definitions get turned into executable code. The classes that are listed there get executed. They get added to the context. Well, that involves reflection. It involves lots of reading of resources from jars. So we turn all that, we pre-compute all that, and turn it into a Java class, for example. Another thing that we do, you can see here in my application, I've got a regular Spring application with some different Spring beans. Well, I want to turn that into beans that get registered in the application context. Well, that involves reflection. Spring starts up and it looks at the component annotation and it finds all the types that have the annotation. It reflectively instantiates an instance of that and all that. Well, we can actually functionally create all that. We can programmatically register all those things using the application context itself. You can say application context.register bean, and you can provide a supplier that returns an instance of that type. Well, we do that for you, right? That's what the Spring AOT is doing here. So you can see, this is all programmatically registering these different types that you've already written. So all the code that you wrote, it's doing it for you. It's translated that automatically into functional configuration. So that sidesteps a whole swath of the reflection and things like that that would have otherwise, slowed down your application, the resulting binary. Now, you can take advantage of functional config by yourself, by the way. You don't have to do that in a Spring native context, but it just happens to be, and it's been there for years. It's been there since Spring Framework 5. It just happens to be a great fit for this. So we transpile your Java config into functional config. You don't need to worry about it. It just works, right? As you can see. Okay, let's start the application up. Now, the first time I run this on my machine, it's going to be a little slower because of the Mac OS security, whatever, right? So customers, wait for it. Where's the port 8080 already in use? That's the first problem. Okay, stop this one. Okay. And there you go. So security is asking me, do I want to allow incoming applications? I say absolutely. And then I control C. Please. There you go. So there's my application, 53 milliseconds, 53 thousandths of a second to get an application that has the full management endpoints, the full embedded web server, a full embedded database, the SQL startup, all that stuff. Right? It's a full regular Spring Boot application. More usefully, this application is also going to take a much smaller footprint. So customers, there's the PID, yeah. So I can say env bin RSS by PID. Okay, so there you go. It's taking 97 megs to run that application total. That's the entire resident, memory of the application in my computer. And I'm using an M1, an Apple M1, which for reasons I don't quite understand, for some reason takes more. You'll actually, if you're using anything Intel, you'll probably find the equivalent application takes less space, but it starts up a little bit slower. So whatever, This is really nice because you can also use our built-in Docker support. You can use the build pack support, right? You just say maven spring-boot :build-image, and it'll create a Docker image for you. If you've got Spring native support configured, it'll create a native image. It'll, as part of the build step for the Docker container, it'll create a native image, compile it on Linux, in the Linux container, and then put that Linux image in the container that you get produced. So you can then, and that doesn't need the full like Ubuntu or anything like that, because you're not using the full JRE. You can use Alpine Linux. You can use a minimal set of operating system primitives to make that work. So that resulting binary, 120 megs, whatever, the whole Docker container could be super small. You could Docker tag, Docker push, and then reference that in your pod or your deployment for your Kubernetes deployment. You're all using Kubernetes, aren't you? Everyone? Okay. We have work to do. It's my favorite YAML database. It's amazing. You got to check this out. Anyway, so that's kind of the you have this to look forward to in Spring Framework 6. Although, as you can see, it's already there today in some way, right? Now, everything there's a whole component model for which we don't have a lot of time that I could show you. In fact, I did a Spring Tips video that looks at the extended component model, how you can dynamically contribute to Spring Native, how you can contribute stuff. So the Spring team have obviously developed most of the configurations for the common sort of use cases, but there are other third-party ecosystem projects that need their own integrations. And so part of what I've been doing for the last several years is going around and working with different community members, including JHipster and JobRunner and Okta and just anything I can think, like a dozen different projects, dozen different open source projects out there, and help them to develop their own Spring Native integrations. Okay, that component model is going to change when Spring Framework 6 comes. Conceptually, it'll be the same. It's the basic idea. You have a callback that allows you to feed into the GraalVM native image compilation. But API-wise, obviously, it'll go from Spring Native and it'll be part of Spring Framework itself. So that will change, unfortunately. But still, your work would not be lost. It'll be, I don't know, I reckon half an afternoon to take the conceptual work that you do for Spring Native today and make it work for Spring Framework 6 tomorrow. Okay, so this is a regular service. It's up and running. I want to build a quick client, since we have 10 whole minutes here. And we're going to call this the Edge service. And I'm going to use Java 17, of course. I'm going to use the reactive web support. I'm going to use Spring Boot 2.70 RC1. So Spring Boot 2.7 is just around the corner. I think this month, in fact, soon, very soon, not today, but soon. And we release Spring Boot every 6 months now. There's a new revision, kind of like Java, right? So we have a project called Spring for GraphQL. Spring for GraphQL is a separate project right now, and we have a separate Spring Boot starter. But in Spring Boot 2.7, that support has been merged in. So we're going to use that here, okay? So GraphQL and reactive web, and I'll hit generate. Okay, UAO. Edge. Now, the point of an edge service is it's the thing that lives at the logical edge of your architecture. It's the first port of call for requests coming in from the outside world intended for your downstream services. And it's here that you can do all sorts of transformations on the requests. You can turn them into different kinds of views of the data. You can enrich them. You can stream them up, stream them down a little bit, slim them down a little bit. You can do all sorts of things at the edge. And normally when I talk to people about this, I show reactive programming because it's great for service orchestration and composition. I show Spring Cloud Gateway, which is a proxy, which is great for HTTP services in particular, because you can do rate limiting and compression and routing and all this other stuff very transparently, right? And indeed, that's one of the big reasons that people like HTTP is it's designed to be filtered, right? You can have two different a client and an endpoint, and you can add 5 different HTTP filters or proxies in between, and the request still works. The client doesn't need to know that there's been this indirection because it's meant to be proxied. So Spring Cloud Gateway is great for this kind of stuff, but I've already talked about that. What I really wanted to talk to you about is Spring for GraphQL. Now, what is this class? I didn't even, okay, Edge. And by the way, that's to bring it all back home. The reason we don't have that automatic image to text file conversion anymore is because that would bring in all of auth, which we don't want people having to do when they build native images, right? So now you can kind of see we're trying to trim that down. Okay, so here's our Edge service. What we're going to do is we're going to build an application that lives at the logical edge of the architecture. And the nice thing about this is that you can build api.spacex.land. Okay, this is a spacefaring company that Might be big one day, who knows? So they have an API that you can use to consume their different APIs. The nice thing about GraphQL is that it's a great way to federate other services. Now, what I mean by that is you can hit this endpoint and you can talk to any number of different services behind the scenes. But it looks like it's just one API, but it could actually be being served or serviced by dozens of different services on different nodes and different computers and different geolocations. You don't need to know about that though. GraphQL makes it easy to have one coherent view of the data. In 2012, Meta, nay Facebook, ran into a problem. They ran into a bit of a tension. Their clients want the data all in one fell swoop. They want it to be compressed and optimized for their particular views, what use case they had for their particular clients, be it Android or iOS or that one person using Windows Mobile or whatever. And they want that all as quick as possible. Whereas on the server side, the inclination, even back then, was to keep these services as minimal as possible, to reduce the surface area and to reduce the responsibilities for them. So you've got a conflict, it would seem. You've got a tension. The client wants the data in the shape it wants it, and the services want to be separate from each other. They don't want to, get jumbled up into one big giant spaghetti ball of mud. So separation, right? And GraphQL kind of is a nice way to get around that. You can get the data in any shape you want, right? By asking for it in a particular way. So here is my query. This is a console that I'm going to use to request data. And let's say I want the mission name. Okay, great. I just want that and the ships. I hit enter and I get that back. Let's say I don't want the home port or the image. I just want the name. Great, I get that back. So I'm reducing parts of the data that I get back, and I'm getting less and less data back. But I only pay for the parts I use. So let's go back to our code and let's create a simple schema to represent the types that our GraphQL service will have. You go to source, main resources, GraphQL, and you can create a new file here called schema.graphqls or foo.graphqls. It doesn't really matter. And all GraphQL applications have a root type called query. There are many types. There are three well-known types in GraphQL. One is query for any operation that reads data. The other one is mutation for anything that changes data. And the other one is subscription for anything that gives you data over time. So like if you have stocks feed data or sensor data, something that goes ongoing, for which you might have otherwise used WebSockets, you could as easily use subscriptions in the GraphQL world. Okay? But your query is where you start. In fact, I think 80% of most applications are going to be queries. These are the things that allow you to read data from the service. And so I've got a type called query that has a field called customers, which in turn gives me a collection of customers. Well, a customer is defined as having an ID, which we saw from the other service, and it has a name. Okay? So this bracket here indicates that this is not a scalar. It's actually, there's more than one value here. It's a collection or a stream or whatever. Okay, well, that's easy enough to build. Let's go ahead and build that controller. Okay, so we'll say, did they change the shortcut for that? It's neat. Okay, so type. I'm going to do, what I'm going to do is I'm going to do something terrible, something that you should never ever do, ever, not even when you're all by yourself at home and nobody's looking. I'm going to copy and paste code. So I'll go here, and I'm going to get the type for customer, copy and paste it to my client, which is going to act as a client to that service. And then we're going to build a GraphQL endpoint. So we're going to say customer GraphQL controller. And here I'm going to use Gazunt. We'll use the reactive non-blocking web client. I'm going to build a controller. It's just a controller. People think this is tied to MVC or something. But this annotation has, did you know it doesn't have anything to do with HTTP at all? Org Spring Framework Stereotype Controller. Anything that takes a protocol and adapts it to business logic, that's a controller. So we have RSocket, GraphQL, WebSockets, HTTP, MVC, all that stuff. It's all controllers, but they're not tied to a particular protocol. Okay, so here we go. Add the constructor arguments, and I have to implement the schema now. So the first thing I want to do is I want to create a method that returns the customers when asked. Okay, so I go here, and I'm going to create a schema mapping. The type name is equal to query. And the field name is equal to customers, all right? Publisher of customer, customers, all right? And I'm going to say return this.http.get.uri, http localhost 8080/customers.retrieve.body2flux customer.class, okay? Now, I'm just returning the data back. Now this is a schema mapping. This is the generic, think of this like request mapping in Spring MVC or Spring WebFlex. It assumes any particular type and any particular field. But as I said, the type called query is a well-known convention. Every GraphQL application will probably have a query, okay? So there's actually some convenient meta annotations you can use called like query mapping. Query mapping assumes that the type name is equal to query and the field is derived from the name of the method. So this is identical to that, okay, semantically. Now, what I said earlier about being able to stitch together different API sources is that you can actually add, you can create a new view of the data that is separate from the actual representation of the data behind the scenes. So let's say I have another field called profile, okay? Profile. And I'm going to say type profile. And the profile will be ID, and whatever, just ID, okay? So it's going to be another type that I haven't introduced yet. Let's just create another service here, another type. So record profile, come on. And it'll be integer ID, okay? Just another type. Well, something needs to resolve that. So here, I can use schema mapping. The type name in this case is customer, and it'll return a profile, so profile. Now, of course, in order to resolve the profile for a given customer, I might need to call another microservice. In order to do that, I need the ID of the customer. So I can ask Spring for GraphQL to give me the root entity here. So I can say return new profile, voila, and it'll just be, let's say, customer.id. Okay, so that's going to actually do the work of getting me the profile for each customer. In this case, though, what I have is like 10, I have 8 different customers, and that's going to make, in this case, it's just returning new, but it might call 8 different, might make 8 different network calls, right? And if, you can get around that using something called batch mapping. Why isn't this detecting my application? Okay, oh, it's going to run on the wrong port. Port equals 9999. Okay, take 3. I need a web client. Let's see here. Bean web client. Whoop, nope. Web client, HTTP, web client.builder. Build. Okay, good stuff. So, okay, go to, and I also want that graphical console, so I'm going to enable that as well. I'll say graphical enabled equals true, restart. Okay, localhost 9999/graphiql, Graphql, get it? Okay, so there's this query, customers, ID. Okay, I get the IDs back. What about the profile data? I want that, so I get that as well, right? So I'm able to create this new view of the data where the customers and the profiles are all related to each other. The consumer doesn't need to know that these are actually different microservice calls, right? And that's the point. My client gets the data all in one fell swoop, and they don't pay for what they don't use. If the client needs just the overview for like the search results, great. Then just show the name and the ID number maybe, and then for the details, then you can show the profile and the account badge and all that other stuff. And you only use what you pay for. You only pay for what you use. My friends. We've only just begun to scratch the surface here. There's so much more to look forward to. One thing that I would have loved to have shown you here is we created a client basically by using that controller, and I just did the HTTP call in the code. Normally, when you want to make a network call to another service, I love to use things like Spring Cloud OpenFeign and Spring RetroSocket. Spring Cloud OpenFeign makes it easy to take an interface and turn it into a declarative HTTP client. Spring RetroSocket does the same thing for RSocket. And we also have Spring Cloud Square Retrofit support as well, which is another way of doing interface-based HTTP clients. And they're not compatible with each other. They're different engines that have different benefits and different protocols. All of that is being homogenized in Spring Framework 6. There'll be a basic mechanism in Spring Framework 6, on top of which we'll have one HTTP client and one RSocket client mechanism as well. And that would have made me writing the code to talk to that HTTP service considerably easier. I want to thank you so much for your time today. It was a pleasure to see you. It was so good for me. I hope it was good for you. Who got something out of this? Good stuff. I appreciate it. Thank you so much for being here. Appreciate you.